Okay, I think it's going to fill up as much as it's going to. So let's get started. We're going to talk about the rest of the trait system. That's the goal here. So if I go back here, I'll kind of close this stuff and go to, my basic traits implementation. What I want is my traits component implementation. Let's zoom this guy in. I've got this going. We've tested the traits. We've made sure that they basically work, or that they're attached at least. So let's look at traits.lua with the traits that we have. What I want to do is I want to be able to change different, add different behaviors essentially based on whether or not they have a trait. And, and anything that has to do with programming, and unfortunately I didn't save the last thing, so I can't just keep adding to it, so I'll just create a new one. And in programming, when you're talking about updating, you basically have a push or a pull. It might be called more of a pull, or I guess maybe pull. Same difference. But you basically have these two general methods for updating things. For updating things between two objects, right? If I have these two objects, well, really just one arrow. So, does this object push updates onto this other object, or does this object pull updates from that object? And it helps with decoupling or knowing like which things need to be coupled, all that kind of fun stuff. So that's kind of what, that's the big question that we have right now is how are we going to do it? And I mentioned this in the previous stream where I think the right thing to do is to utilize a system that I already kind of have. And I'll show you how it works briefly with transform. So I have this transform component, which has all sorts of functions and things. Let's see. If I look at, we'll look at full transform. So this is the full transform. Here it is. These are the various transforms that I have. I said that one of the big advantages of doing this kind of inheritance, like hierarchy, is that I have different kinds of, I can have different types of transforms. So I have a point transform, which just has X, Y, Z, and speed. And I have a symbol transform, which adds in offsets, as well as width and height. And I have a full transform, which adds on top of that the ability to rotate. And this is all 2D. So Z is actually more of like a layering thing. So that's what all of these guys are. Now, the reason I bring this up is because this guy at the very top is this move callback handler. So I have the ability to add on move callbacks, on resize callbacks, and on rotate callbacks. And these callbacks are these sort of on-move callback types. If I dig into this, it's this thing called a fast delegate, which is a system that I use that I grabbed from the internet long ago. That's just a very, very fast delegate system. And one of these days, I'll probably convert a bunch of this stuff over to a better system. There's not a super easy system for being able to store member functions. The only sort of easy way to do it is to use standard function, which is crazy slow in many instances because it has to allocate memory. Fast delegate doesn't allocate any memory. It's sort of non-trivial. There's a lot going on here. In one of my videos, I'll probably actually do some kind of basic talk about how to make this stuff work. But the idea is that it's essentially a delegate that acts somewhat like C# delegates. At the end of the day, the thing to really consider about this is that it is essentially a callback function. It is a function pointer, like an efficient function pointer, or an alternate way of doing a C-style function pointer to a member function. Anyway, so I have a list of move callbacks, resize callbacks, and rotate callbacks. And then what happens is, whenever I move, let's look at one of the move functions. Here's a move function. So if I'm not resetting, and I have different move types. I mean, this gets complicated. But basically, I set the old positioning, I set the actual position, and then I call on move. So let's go back up here to see what that looks like. All that looks like is literally loops through all of the callbacks and calls the thing. That's all it does. And that's it. That's what pretty much all of these do, is they just call the thing. So that's the idea. And then this is the base class. It inherits directly from transform component, and then point inherits from on move, and then these guys inherit from each other. So simple inherits from point, and full inherits from simple. So that's the idea. Now, the reason why I say this is because this is the pattern that I basically follow whenever I need to do this kind of thing. So someone can register with the transform and say, hey, I want to do something here. An example of this is in, let's see, callback. I think it's in here somewhere. Here it is. In Collider, register transform event. So if somebody moves or if they resize, then what we need to do is we need to, the collider, the collision system needs to know. It needs to know if this resize needs to push them in some direction, or if the move needs to push them in some direction. Resize specifically needs to update their collision cache. And we can even see what they do. So internal on resize literally says, hey, probably what we need to do is dirty the cache. So that means that because it keeps a collision cache, which just makes things faster. So it has to dirty the cache, and then the internal on move says, also dirties the cache as well, and says, hey, we need to actually process some kind of collision and so on. And we might need to probably we need to reinsert the node into the collision tree. The collision tree is a big quad tree. And so there's like a bunch of stuff that we need to do in order to make this work. This is how this kind of stuff is generally meant to work. And so this is the pattern that has already been established for basically sending these types of events to other to components. So you register for the thing that you want, and then those things can be notified. So that's what I want to do here. If I go to transform component, I'll actually go directly to it. You can see that all these move callback things are in that base. So that's what I'm going to do here is I'm going to go to trait component at the very top here, and I'm going to add all of the things that I want. So I want on trait added. And then, with these guys, it's going to be the same type of thing. I'm going to sort of create this sort of callback. And you'll notice that I've created this entity component callback thing here, which exists, in its sort of core place. So I'm going to do the same basic thing here. I don't really want these guys to live here. So I'm actually going to create a new folder. Oops, that's not what I wanted. Come back up out here. Where I'm going to create a new thing. So what I'm doing here is I'm going to say trait system. I'm going to say trait component callback .h callbacks.h. Yeah, that looks right. I'm creating it in its own sort of file because it's kind of wonky and ugly. And I like to sort of, much like, let's see, entity, trait component callbacks.h, and much like some kind of, pseudo-utopian society, things that are ugly are sort of relegated to somewhere out of the way. So let's, if I go back here to this, where are you, entity component callback, I'm actually just going to copy and paste this whole thing because it's sort of horrible to type out. Object system types. I don't know if I'm actually going to need this. I don't know if I'm going to need this either. So, because I have to disable, because fast delegate has all these warnings, so I have to kind of disable these warnings. I'll do this. And so let's create these fast delegates. So what I'm going to do is I'm going to have, I'm just going to copy and paste this guy. Oops. And I'm going to say let's not do this. I'm trying to get away from using type defs, so I'm going to say using on trait added callback equals, this thing. And instead of pos type, I think I'm going to pass it the trait. Right? That feels, oops, not ptrait. I think I'm going to pass it a trait pointer. So that means I'm probably, and we'll put it up here. That feels right. And, oops. My accuracy is not super high. I don't think I need any of this other crap. I do need make delegate. Why are you unhappy? Oh, these are the same, first of all. So let's see, on trait removed callback. I think these are the only two that we need for right now. We'll see what this guy's complaining about. Using Dougal make trait is unused. Oh, that's fine. I don't care about that. I don't need any of this stuff. Okay, so this is our trait component callbacks. So this just sort of defines our callbacks. Great. So if I go out to, this is the room system. If I go out here to trait component, also the wrong one, this guy. Now I can say on trait added, on trait added callback, which includes my thing. Callback equals 0. I'm gonna do the same thing on trait added. I'm gonna say, add on trait added callback. That's sort of a wonky thing, but that's okay. On trait removed callback. So these are going to be our two little functions that are going to add and remove these types of things. So let's go to trait component implementation. This is transform. The problem is that it's TRA, and so my brain thinks that it's the same thing. Here's the implementation. So let's create our little override functions here. So again, override final. It makes me sad every time I type final because I know I'm never going to get that optimization. Okay, so trait component implementation. So this is cool. Okay, so the next thing that we want to do now that we have this is we want to create basically our list. So this is similar to what we had here in transform component. Whoops. This guy where we had these sort of lists. So I'm probably going to do this type of thing again. And again, all right. Again, I'm trying to kind of go to usings. So trait added callbacks equals EASTL vector on trait added callback. I think vector is the way to go here. Removed callbacks. The reason I'm using a linked list in the other one, at least the idea, was because often you'll have something get destroyed and have to remove itself from this list, and it felt faster, but it's really not. So it was 10 years ago or something that I wrote all that code. Maybe not that long ago, maybe 5. So it's just probably this is actually what I want. Let's do that. Okay, and so then let's say trait added callbacks Great, and so that's it. That's what we've got. So the added and removed callbacks, basically I'm going to loop through these and call them, just like I do here in this transform implementation, which is down here. Literally just loop through this stuff and call all the appropriate things that I want. Interesting, I have a collision log here in transform. Cool. Okay, so that's it for this guy. Now we need to actually implement these functions. So let's do that. Oops, come on. Definitions, yes. And so these guys are going to be down here. Now I'm not going to do this here, but as this is getting bigger, I would actually create like block comments. You know, it's not super fun to watch me create, you know, exactly 120 dashes here and like create some comment. So I'm not going to do it now, but like it's worth noting that that's probably what I would do in this particular instance. Okay, so on trait added, this is pretty straightforward. Trait added callback dot in place back callback, and then this is the same sort of thing. Traits added callbacks. Erase unsorted. What do you want? Do you want to type? You want to position? Okay, so I have to find it. For auto it equals m. Oh, this is remove. Whoops. I forgot two very important functions. I'm already trying to write them. Remove. Right? I need to be able to add and remove these. Implementation. There we go. We'll add these guys as well. Generate definitions by declarations. There we go. Okay. And we'll start doing that here, but you know, this is just a copy and paste of this, except that it's in trait removed callbacks. Okay, so trait added callbacks, int equals trait callbacks dot begin. It is not equal to trait added callbacks dot end plus it. So good times. Oops. Man, my fingers are off there. Okay, so now I can do erase unsorted. Erase unsorted is not a standard thing. Oops, not callback, it. And then I have to do the if statement, of course. If star it is equal to the callback that I care about, then we do this guy, and we're done. Okay, cool. So erase unsorted is not a standard STL thing. I use EASTL, as I've mentioned before, and EASTL has this. Erase unsorted is just does the swap trick. So this is not a sorted list, so who cares? So the nice thing is that this is constant time as opposed to linear time, which is nice. So instead of being essentially 2n for going through this, or I guess truly n, because I have to walk through and then walk everything back. So, you know, old school, this is big omega of n. Like, there's no way we can get better than n. Now it is actually, you know, big omega of 1, essentially, but, like, it amortizes a bit faster. So anyway, that's what that is. I'm going to do the exact same thing here. So, philosophically, do I care about this? Yeah. One thing that I could do, because now what I've done is I've copied and pasted code. So what I might actually do if I want to be like super pedantic about this is I might say something like add, you know, callback, and then I might say, you know, one of these guys, like I might template this or something. So there's like a, you know, ways that I can not have to copy and paste this, because these are literally copied and pasted, and that makes me sad. I'm probably not going to bother right now. If I had a third one, I would definitely do it. 2 is just lame. 3 is potentially dangerous. So here's why it's potentially dangerous, because, you know, if I'm talking, I can very easily forget that I'm doing this. One thing that I also think I want to do is I want to change these to Booleans. And I'll do that up here. Just thought of this. I do this in various other things. You know, this happens as well, because if I get here, I basically want to say return true. And then if I get down here, I'll say return false. So this is going to return true if it found something. And it's going to return false if it couldn't find the callback. And so it lets me, you know, worst case, I can just assert or something like that. Like that's the most lame case. But it's reasonable to have that kind of thing. And of course I have to do it in two places because, you know, I have this. So it's bothering me enough right now that I actually probably will not, you know, it's not super worth it to do it in this stream, but I probably will actually extract at least the remove into its own sort of function. Essentially, I'm going to just change this guy, this removed traits callback. The thing is, where'd you go? I don't know where it went. I'll just do this. The thing is I've just sort of realized these are literally the same callback, right? So on trait, you know, I could say added or removed callback. Like it's literally the same exact callback. It's some delegate with this guy. So why don't I actually just do this? Right, because it's the same exact thing. It also means that, let's say trait callbacks is just that. And then I just happen to have, oops, come on. I just happen to have this. Not super excited by this name. Maybe I'll just say, I'll leave it. It's descriptive. Okay. That means that I also have to change this. There we go. And yeah, that should be it. I should change them here, of course, too. Cool. That's it. So that's going to make life a little easier. All right, this is bothering me enough that I'm actually going to do this now. Bool remove trait callback trait callbacks trait list, and then this thing. This is actually bothering me enough that I'm just going to make this happen. There we go. That's so much better. Okay, and then of course this is going to be trait list. There we go. And now these guys just become, you know, return, remove, where are you? Remove trait callback. This is the added one, so added callbacks, callback, and then this guy. So much better. Trait removed callbacks. There we go. What are you complaining about? It can be static. Fair point. Doesn't need anything. I don't need that extra little thing. What are you complaining about? That's fine. That's it. So that's what we've got here. That makes it a lot better, a lot easier, and now we have this whole thing that we can do pretty easily. So the plan at this point is systems that care about traits being added or removed need to mention that. The only system that we have right now that's going to care about it, this gameplay system that cares about it, is this guy, the AI component system. Wrong system. Sorry, is the crew, where are you? These are interfaces, crew AI component. So it's the AI system. Because in here I'm going to have a schedule or whatever that might need to be updated. So the way that I have to do this is I have to say, I have to create the Postinit function. We saw that last time. You're not right. So let's dig through. I think is loading. Yeah, that's it. Oops. So let's do that. So is a Postinit. So I said this last time. Postinit happens after the after all components have been loaded. So I've guaranteed that all components are loaded. And so the sad thing is that this is going to tightly couple these guys together. I don't know a way around this with the current system that I have. Crew component. Yeah, so component interfaces, trait component. This is what I want. And you can come up here. Basically in here, what I have to do is loading. Do I want this? I don't think I care about this. Unused param is loading. Okay. I need to basically say trait component. It's a weak pointer. The trait component equals owner.get component trait component interface ID. I really need to templatize these. And I'm going to check. No, I'm going to say if p trait component dot is valid. So if we don't have a trait component, it's cool. Like, I don't care. We're not going to throw an error or anything like that. We just say, hey, if we have a trait component, probably we want to add on trait added callback of our own thing. I'm going to say I have to basically pass in the delegate. So there's a whole syntax that I have to do, which I'll look up in a second. Come on. Add on trait removed callback. So these are the two functions that I need to basically do. That also means that now I need a destructor. Component. Oh, crew AI component. I actually might want this. I actually want onDestroy instead of the destructor. I think that's what I want. Oops. OnDestroy is called before anything's actually destroyed. And so I think this is when we would stop caring about any kind of updates, to be honest. Pretty sure that's true. Let's look. Where are you? OnDestroy entity event. Here, let's change this. Too bad. All right, this is maybe not going to go well. Oh, there we go. Collider OnDestroy and Collider base world footprint. Where are you actually called? All right, instead of just poking through here, let's actually look. Here it is, entity.cpp. In a destroy function, here we go. Explicitly destroys the entity. Destroy it with entity event. Okay, so yeah, this happens before the destructor because it's going to loop through. It's the first thing that happens. It's going to loop through and call onDestroy. Then it's going to actually destroy everything. So all of the entity components technically exist. Interesting. Okay, so let's do that. It's always fun when you rediscover ancient comments that you wrote a long time ago. So I think what I do want this then. Let's kill all these things that I've just opened. Collider, yeah. So I think I do want onDestroy. Okay, so onDestroy, not that it matters that much, but we'll basically do this thing because while the trait component may have already been destroyed, yeah, this is interesting. Do I actually want this? I may not actually want this because the entity is being destroyed. I don't know. actually don't think I want this because the entity is being destroyed, so it's going to kill all that stuff anyway. Let's not do this for now. I don't think this is going to cause issues, but we'll find out, won't we? Okay, so I'm going to go to collider.cpp, and I'm going to search for that, add, and I don't want whole word, add on move callback, just because this make delegate syntax, I'm basically going to copy and paste, because I always forget all the things. Okay, so this is going to be crew AI component : on trait added. And then, did I miss anything? No, this is going to be the same thing. On trait removed. And since we're doing this through function pointer, these are actually going to be private. On trait added. Trait. Come on. On trait removed. And then, of course, I need class trait. And then we just need to create these functions, and we are almost done. Come on, buddy. What time is it? Okay, good. This stream feels like it's an hour. So I'm actually making good time. On trait added. So what I'm going to do here is I'm going to actually log. What's a reasonable log? I don't really have one here, so I'm going to add one. I'm just going to add an AI log. I don't actually strictly have to do that, but I do it by convention. I'll add it here and turn it on. Let's turn the action system off. That's very spammy right now. Script is fine. Let's turn the world off. Let's turn the crew off. So I'll just have a generic AI one. Okay, so log AI. And I'm going to say adding trait. P trait dot get, and of course I have to include that, don't I? Dot slash traits trait dot h. Trait. What are you doing? Come on, IntelliSense. Come on, IntelliSense. What are you doing? Trait dot h. Okay. Oh, that's right. I have trait instance. I changed all this. Son of a bitch. Okay. Whoops. So all these places where I did trait star, I have to do trait instance star. That looks right. No files are found to look in. Oh, I'm doing look in. Obviously, I'm not going to look in whatever that was. Entire solution. Trait instance star. Including external items. No, that's not what I want. Entire solution. I don't want to include external items. Entire solution. There we go. Go. Yes. Beautiful. Okay, hopefully that just saved us. It didn't though, because I also have class trait everywhere. All right, I want to change this exact thing with class trait instance. Go. There we go. All right. I would say that one of the most, I don't have my list anymore. Oh well. I'd say one of the most important programming skills, debugging is super important, but is knowing how to use your search tool. Search, find, and replace. And what I did was easy, but there's this other version here where you can do regular expressions. I highly, highly, highly recommend that you learn how regular expressions, you can go to this regular expression help. Oh, I have no idea what it just did. Did it open a web page? It did. You can go to this regular expression help and see how it works. Highly recommend you do it. Regular expressions have changed, it changes the way that you interact with this stuff. It's super useful. Okay, anyway, back here. Get display name. That seems good. Whatever that is. Whatever the display name is, it'll do. And then we'll say, good God. Moving trait. You know, I'm going to change this. Traits. This seems not right. I am going to keep AI, but I'm going to create a new one. Traits. If you're wondering, the stuff down here is game specific. That's the idea. Again, my system doesn't actually care that I put these here. I just put these here because I always, like, I'm not going to remember which things are which. It defaults to 0 anyway, so I can actually put any string I want. But I'm not going to remember that. So, okay, traits. The reason I'm doing this is because this is going to get really, no, go away. This is going to get really spammy. So screw that. Let's see. So we're just going to say that I'm adding and then I'm removing a trait. This should work. Group component AI on trait added. This is interesting. What are you complaining about? This is all a class or namespace. It literally is. No, it's not. I have an extra N. I shifted the N. There we go. Okay. So that should work. I'm actually pretty convinced I don't need this. Let's kill that. And this. Let's build and see if this works. Cool. This looks like it's going to work. Okay, so the issue that I have now is one that we've had. We've just been ignoring it. So if I go back to my trait component, we've got all of our initial traits here in init, and we can't do that. And the reason why we can't do that is because when this trait is added, when I call add trait, I need to loop through all of these trait callbacks, right? I need to go through all of these things. That's something we haven't added yet. I'm just trying to see if this compiles. So because I haven't added all of those traits yet, yeah, everything compiles. Here, I'll show you. So when I call add trait, I place the trait, and then I need to call, I'm going to say notify, let's say on trait added. Do I want to do this? Maybe I don't want to do this. I'll extract it if I feel like I need to. For auto, I'm going to say auto callback in trait added callbacks. Callback p trait. And I'm going to do the same thing for remove. Of course, this has to be reversed. I have to do a lot here, don't I? Okay, so I have to actually manually find it. Does it have a find? Oh, it totally does. What's find as? I actually don't even know what this is. You're not gonna... Oh, there's a whole bunch. Actually, I have no idea what find as is. Let's learn something new together. Unordered map. Let's just look at unordered map. Unordered map. There is no find as. It's an EASTL thing. Okay. I wonder what it is. Should dig into this and figure out what this is. Find as. You're not really going to tell me, are you? Hash table find. Do find node. Well, I'm not going to sit here and mess with this. Can we just as an industry, for the love of God, get away from this kind of shit? Like, holy shit. I have no idea what any of these template parameters are. I mean, K and V, key and value. A, is that the allocator? That feels like it could be the allocator. EK, I'm not really sure what that is. Equal, no, this is the equals check probably. God, I don't know what the hell this is. 2 hash plus another hash. I have no idea what this shit is. So please, for the love of God, can we please, as an industry, move away from this convention? This is terrible. Implements a find whereby the user supplies a comparison of a different type. Find as documentation. Where did you find it? Because I didn't see it. It doesn't seem like it's a standard C thing. I didn't find it in here. So it's some kind of other thing. Maybe they have it up here. I don't know. Yeah, link to the documentation if you can. That's neat. That's not something that I need though. I just need a regular find. Right? Yes. Okay, so auto find it equals find trait ID. So we're gonna look up this guy. If find it is not equal to m traits.end. Yeah, this guy. Then we basically do this. Then I go through and I call this callback, passing in find it dot second. You know, what do you want? Maybe const. That's fine. The whole point here is that, so obviously we need to call this before we actually erase this, which will then cause the thing to get destroyed. Now, my other question is, if I do this again, it's going to do a second hash lookup. And I don't want to do that. So let's actually go back to unordered map. This is why a lot of times I tell people when they're asking about, like, I actually had this in a class. I teach an improv acting class. And I had this, I had a student telling me, like, he does programming stuff. And he's like, I don't really care about, the underlying implementations of data structures and all that kind of stuff. And it's like, okay, that must be nice. I very much care about that. Let's look up erase. Cool, it does have an iterator version. And so you'll notice that, removes the element. If I look for complexity, average case of constant, for one, which is the iterator position, worst case is size. Really? I have the iterator though. What? It seems stupid that if I have the iterator, like for the key, I get it. Average case is, like worst case is size. I don't know why if it's an iterator. That seems stupid. Because I have the iterator. I'm pointing right at the element that I need. It feels like that it wouldn't need to do anything, that I have the direct thing. C.size. Oh, is it using an array under the covers as the chaining element? I don't know. That's something that's interesting to look up. Also, EASTL might do its own thing. Let's go back out here. And anyway, what I want is, instead of doing erase of trait ID, which will guarantee another hash lookup, I'm going to do erase find it. So I'm erasing my iterator. This should be, because probably what it is it's probably using some kind of chaining, so it might have to rewire something, so I might have to search through that. But I have the iterator directly pointing to it, so it shouldn't. It should just rewire the linked list if that's what it's using under the covers. It should be constant time. I don't see why it wouldn't be. Anyway, so that's what we have here for remove trait and for add and all this other stuff. So we should be good here. You can probably be const, right? Yeah, that's what this is complaining about. That's fine. So the problem here is in initialization, I call add trait. Add trait, in turn, will try and loop through some callbacks because we have side effects that need to happen. The problem is that we may or may not actually have the callbacks added because we have this crew component AI, which in its Postinit will go in here and do this thing. So it's not guaranteed what the order is that all this stuff happens. So that's kind of the issue. So we have to figure that out. There's a chicken and egg issue that's going on here. I have to kind of think about how this is gonna work, because I need to be able to add this callback in here. But these initial traits are actually added. So there's a bunch of different ways to do this. There's like postinits and all this other kind of stuff. Yeah, there's a bunch of different ways to do this. I might not support an initial set of traits. That's one possibility. There's another kind of hack that we can do that I might end up doing for this, which is sort of lame. And it's the only thing I can actually think of, to be honest. All right. So to describe the problem more directly, basically I am creating an entity. Well, I'll do it like this. So this is my entity, and it's going to have a bunch of different components in it. The order in which these components are created, so I'll create, and then call my init, is not determined. Which is not actually true. It is technically determined because I can go to, technically they're actually in this order. So in my case, it's going to do collider, whatever this generates, the clickable, crew component, trait component. It's going to do it literally in this order. But I don't want to rely on that. So it's going to init all of these. Then once that's all done, it's going to go back and postinit all of these. So the idea is that now anything that requires, any initialization that requires me to care about other components will work because I just throw that in postinit. The real problem is that I need to figure out when to register. So I have one guy here and one guy here, and they need to talk to each other in some sense, because one guy needs to register for these events. So my trait component needs to say, hey buddy, I need to do some stuff with this. So it has to happen here in this postinit. The other problem is that it, other way around, not traits, sorry. AI needs to say, hey, I care when you add traits, just so you know. Then the other issue is that now we have this like sort of other thing where we say, hey, I need to add some traits. When am I going to do that? So I kind of need some kind of like post init. So how do we solve that? Well, I can think of a few ways, and I'm kind of thinking these off the top of my head. One, we literally create a post init. This is not scalable. And probably worse, it's a system change. I kind of don't want to do that. Number two, I could queue up an event. The way that would, so events are processed in the main loop on the following frame. So any event that's queued up will be not exactly the following frame, but it will happen like later on as part of the main loop. One of the stages is process all the events. So if I queue an event that says it's basically this guy. Queue event for initial traits. And this is kind of a hack because what I'm doing is I'm going to queue this event that's caught by the same guy that's queuing it for no other purpose than to basically delay the addition of this. The advantage is I can do that in regular init and it's fine. And then all those initial traits will be added essentially the following frame. Number 3, which might be the right way to go, I don't know, is when, I think I've done this before, when all, how do I put this? When AI registers, the trait system will just directly call all the callbacks. So that's the other way. Those are the 3 ways. So as soon as somebody registers and says, hey, I need to be registered for these events, it'll say, oh, hey, these traits have already been added. I think, while amusing, the others are amusing, I think this is the way to go. I think what I want to do is, I think that's the right thing to do. I think we always want to have those callbacks. So that's what we're going to do. Cool. And that was not like a big lesson. Like I literally made that decision as I was writing all that. Okay. Where are we? On trait added callback. So this is all fine then in Postinit. And so then I think it's going to be, yeah, I think this is all fine. So then down here in trait component implementation, when we do this registration on trait added, we're going to have a special thing where we say for auto trait pair in traits callback trait pair dot second. Are these pointers? Yeah, they're pointers. So literally we're just going to do this. This seems like the right thing to do. Because I think that's always the case. So we basically say, if you're registering for these trait callbacks, then probably you want to know about the traits that we already have. So this seems like the right thing. We don't need to do the same thing for removed, because it's like, we don't know any of that stuff. So this should be okay. Components are never added or removed dynamically at runtime, so I don't need to worry about any of that stuff. The last thing I need to do is I need to move this to Postinit, and then I think I'm done, except for maybe some basic other things. Postinit, what was it? Bool is loading, that sounds right. Override. And final, why not? We'll do this and this. So I can't just do this, right? I can't just copy and paste this guy, although I'm actually kind of going to. Now there's another question is, I have this initial traits sort of variable that I need to deal with, that I need to kind of hang on to. So the question is, because I need to hold on to this until this thing gets called again. So how do I hold on to this? Well, there's kind of this shitty way, which is likely what we're going to do for now, which is initial traits, and I just literally store it. So in this case, if initial traits is table, then initial traits equals initial traits table, and then that's it. And then there's an else though, isn't there? Yeah. So actually I want to keep this, and then do that. So I can delete this to do. That feels like it will work. And then here it's just the same thing. Or here in Postinit, I'm going to say if initial traits dot is table, then do all this stuff. Except now, of course, I need to use this. There's no return, so I'll do this. Again, there's no return. No return. So that means I'll just kill this. that. There should be no way for this to happen. So I'm actually going to say check m initial traits dot is table. This should be impossible to happen because I've set it up here to never happen. So I'm actually going to change this whole thing into an assert. There we go. So this should be okay. This should work. And then I guess I want to do it in all of these cases. It's a little annoying. M initial traits dot set nil. I guess I do need to return. All right, actually, let's do this. This is actually going to be easier because I'm in a loop. Let's just break. Because I don't have a return value, so I can just bail out of this guy. Yes, yes, yes. Because then here, we just make sure that we do this. Now initial traits is going to be nil. It's not ideal. If you actually look at script var, which is a bleach Lua variable, and you look at what it stores, it stores an internal state, which is a pointer, and it stores a reference, and then it stores an internal reference count. So 2 pointer, so it's 16, so it's 20 bytes, basically. So it's not huge. So it's not, this is all this crap is just functions and stuff. So it's not ideal how much I'm storing. It's 20 bytes. But, an extra 20 bytes, it's not a huge deal. It's not what I would want to do. One advantage if I go back here to this, not you, this is my AI stuff. One advantage to option number 2 is that I would basically queue up an event, and then that script var would be stored on the event, and so it would go away forever. That would be an advantage for that, but I'm not doing that. So there we go. Okay, that's it. That's it for this thing, right? Unused param is loading. I think that's true. I think we always want to do this. Cool. Build this guy. Run. But I'm hoping, I feel like I've missed something, but I'm hoping to get a whole bunch of spam about those security red shirt guys. Yep, there they are, adding trait. I mean, there's no display name apparently, but I'm adding the trait. So let's go to the traits data file. Yep, I didn't add a display name. I should add that for everything. I shouldn't. Should I add it? Yeah, why not? Display name is probably wrong. Equals test tag. I probably want a debug name as well. Or maybe not. Or I could grab the ID, I suppose. So there we go. Oh, I put it over here. So there's all my test tags. So all the security people have these test tags. And I can click on this guy and we still get all of our things. So now I have the full stack, everything. So I'm going from data, loading it into the system, and I have another component that cares about what's going on. And right now, literally all I'm doing is calling add, this log, but that's all I need right now. The next step, which I'm not going to do because we're basically out of time, and it's a whole other can of worms, is I'm going to add it to my scheduling system. Because that's the whole point, is I want to be able to now go to the trait and say, okay, where's the trait instance? Go to this trait and say, okay, give me my schedule, because we have this schedule ID for the template. So I'm going to say, give me my schedule so that I can see it. And that's it. I mean, that's all that we really need to do in this particular case. So that's it. That's kind of the end of this system. The system is going to grow. The whole purpose of this is to be able to allow me to add different things. So I'm going to keep adding to these trait definitions. I may or may not have some kind of inheritance hierarchy here. I don't know that it's super necessary right now, but I might have it, or I might even create some kind of piecemeal component sort of internal system for trait definitions. It really depends on how they end up getting used. I have some suspicions as to how they're going to get used, but the reality is that, you can create this massive architecture if you want to. But what you're going to end up doing is throwing half of it away anyway, because it's just the design is going to change. That's how it works. As you start to use the system, you realize it's going to be used in different ways. So Mike Acton has an interesting saying, which I like to use in some of my classes, and one thing that I like, which is, and I don't know if I'm even saying the saying right, so maybe I'm butchering this, but it's something to the effect of, it's not as important to write super optimized code. It's important to write code that is easily optimizable. And I believe the same is true for architecture. It doesn't matter if you're writing this like crazy, super perfect architecture. It matters that your code is easily refactorable, that you can make changes to it without upsetting the entire system. Whole purpose of architecture is making things easy and mitigating change. Making it easy to use your system. And how do you use the system? By writing code. So it needs to be easy to write code around your system. So the way that I have this set up, I have a trait definition and I have a trait instance. So it's easy to shift around runtime versus non-runtime data. So memory optimization is relatively straightforward. Performance optimization, I'm not that worried about it right now, but I can make changes if I need to. In terms of like pure architecture and adding things, I can have hierarchies and layers of trait definitions. Trait definition can turn into a base class, of which there are many subclasses. It's not going to change how trait instance works really that much. It might change some of these getter functions to like ask if it's a particular thing, or maybe trait instance is actually more of a component sort of thing, and the trait definitions are the components. So trait instance, has some list of trait behaviors, and all I'm doing is I'm asking if you have a particular behavior and then running that behavior. That's another possibility. And so then trait definition is essentially the set of components. And all of those changes can be made without really touching anything outside of this trait folder that we created. Trait database is probably going to change, but all the stuff outside of it that needs to care about traits doesn't matter, because they're going to get a trait instance of some kind, this guy, and they're going to ask a bunch of things to these accessors or whatever functions I've got. Really, that's all they're doing. They're asking questions of the trait instance. That's it. So as long as that interface is not necessarily changing significantly or at all, it doesn't matter how it's implemented on the inside. So that's kind of the advantage of having this kind of architecture. Is this what I'm going to ship? I don't know. If traits end up being something that really only affect schedules and some other basic AI stuff, maybe. This might be nothing but an icon, a schedule template, and some mapping of, AI, utility score modifiers. It might be nothing more than that. That might be the entire purpose of these traits. And if that's the case, the architecture probably won't change that much. If I start adding like tons and tons and tons and tons of things, then I might revisit. But for now, this is, I think, a reasonable beginning to an architecture. And my next step, which is what I'll do, and I'll probably do this once I end the stream, it's not an interesting step, is to go through and I'm going to comment stuff. Now that I have an idea, there's a cleanup phase. And if you're curious, at least on some, oops, that's not what I want. At least on some level, I'll show you the beginnings of it, because what I usually do is I go into source and I do that, like just a general add. And so let's take a look. Like I've added a bunch of files in here. Yeah, this all looks right. So I'll add these files. I'm going to do it again because sometimes if I've added folders, it misses things. Okay, so that's good. So those are all the files that I've added. If I go in here, I'm going to do the same thing. What data did I add? Looks like only the traits. Great. Then I go here to this outer level. I don't think I added any actual code into the engine. Let's double check. Nope, doesn't look like it. So now what I would do is I'd say, okay, well, what changed on the engine? And so, this is, come back. Come on. This is, nothing changed. This changed. This is my compile time thing. So this is an engine. This is just a thing that I'll change. So I'd look at the engine, and then I'll look at this guy, and I'll open this, and it's like, here's everything that I changed. Not just for this. There's probably a couple other things because I was playing around with some of the schedule stuff. But I would look at every single thing. What did I change? Okay, I added the trait component. Great. That would actually remind me I have to add it to everything else. Simulation object. I changed the way that names are displayed. Here's my new file. I've traded schedule entry database. I've changed some of this. I'm not going to look at the schedule stuff. Space sim logic. What changed? And so this will let me see, yeah, this looks good. Like I look at every single change that I made, because a lot of times, I would say at least 25% of the time, and with a big change, more like 50% or more of the time, I will find something in here where I'm like, oh, I didn't want to check that in. Like this all looks okay. These look fine. Like that. So I will go through and make some of those. Like I just do this for every single thing. The other thing that I'm going to do is I'm going to go through and, I've added a bunch of these types of systems. Yeah, so here is even one. Has tray. It's a reminder to me that I have to go back and make some of these changes. Yeah, and then I'll go through and I'll comment all this stuff, that kind of thing. So those are the major changes that I'll do. What is the biggest difference between Perforce and Tortoise SVN? It's easier to talk about the similarities. The similarities between Perforce and Subversion are, Tortoise, by the way, is not Subversion. Tortoise is a client for Subversion. There's also Tortoise CVS or whatever, which is a client for, so they have other things. So Tortoise is just a client. But Subversion in particular, which is what I'm using, is the similarities are really just that it's a centralized database type version control. There are many types of version control. I'll go back to this. So, you probably know how Perforce works, but the basic idea is that there is some server somewhere that lives in, on the internet, on the cloud somewhere, and then there are your, clients here, and the server has the official, version of has the latest version of everything, and so what you do is you sync up to the server to get your data and your code and all that stuff, and then you do all your changes locally, and then you push that to the server so that then the other people can pull that data from the server. So what's the difference? So Perforce does that, and Subversion does that. They have I have a server that lives, I think it's in LA somewhere, that I pay for, that has Subversion and also hosts my website and a bunch of other things. And so that's where my code and data and all that stuff lives. That's kind of where the similarities end for the most part. So Perforce has a locking system, so I have to go to Perforce and check things out. With Subversion, you don't check things out. You can go and lock stuff. Perforce is much more robust. Perforce is much more, it can handle much larger repositories. I mean, it's like the difference between Subversion and Perforce is like the difference between a basic Paint program, not as bad as like MS Paint, but maybe MS Paint compared to Photoshop. I mean, they're different animals, and Perforce is massive and can deal easily with terabytes or petabytes of files, where Subversion is not as good at that. The branching is a little weaker and so on. So stuff like that. Locking, it doesn't log for code. Perforce does not lock ASCII assets. You still have to check them out, because you have to know, Perforce has to know that you have the file, but that's not locking. You and I could check out the same files, and then when I submit, then everything's fine. When you submit, you'll have to sync my file and then merge my changes. So Perforce doesn't have that issue. And then binary files, it absolutely locks. Subversion just doesn't have the locking step that you typically do. You can, and I've done it before. So I could go in here and I could go to this file or some set of files and go lock. It's one of these guys in here. Oh, there it is, get lock. And so that's essentially like a Perforce checkout. So I can do it. I've done it before when I've made very large sweeping changes that I knew other people might need to touch those files. So I made a big refactor to the conversation system in a previous game I worked on, and in my Journey game. And I had other people working on it. And so I told them, hey, I'm going to work on these files, check in anything that you're going to. And then I locked all the speech data and I locked all the conversation code files. And I just had a lock for like a day or two, just so no one can mess with those files. So that's what it is. It's just simpler and less robust version control. For my little projects, it's not a big deal. It doesn't matter. And when I work with small teams, if I had a large team, I might care more. But I'm not going to pay for Perforce because it's not worth it to me. I'm not going to use it because my team might grow beyond their minimum set. So Subversion is fine. It's on my server. It works. It was already installed. I pressed a button and then they just enabled it. So it was super easy to do. Git is your other option. That's probably a whole different rant. Cool. Well, that's the end of this. Looks like as my watching list is starting to drop down. So that's basically what we have. If there's any questions or anything like that, as always, let me know. I will be around. So I hope that was useful. I hope you guys enjoyed that. And that's a simple trait system. All right, guys. I'll catch you next time.